A city is more than its demographics. Two blocks might have identical income levels and family sizes, but if one is downtown and the other is in the suburb, they belong to different neighbourhoods. Banksy brings this geographic thinking to spatial biology, clustering cells not just by what they express, but by where they are. Traditional clustering methods like Seurat or Leiden group cells purely by gene expression. Cells with similar expression profiles end up in the same cluster regardless of where they sit in the tissue. This is like grouping city blocks by demographics alone. You might lump together blocks from opposite sides of town. Banksy changes the game by incorporating spatial information. For each spot, it looks at the neighbouring spots and averages their expression profiles. This neighbour average expression becomes an additional feature, augmenting the original data with geographic context. Now similar spots that are far apart can be distinguished. Here is how Banksy works step by step. First, build a spatial neighbour graph connecting each spot to its nearest neighbours. Then, for each spot, compute the average expression of its neighbours. Augment the original feature matrix with these spatial features. Finally, cluster on the augmented matrix. The result, spatially coherent domains. The output is a set of spatially coherent tissue domains, contiguous regions where cells share both expression profiles and spatial proximity. These domains correspond to biologically meaningful structures, tumor cores, immune infiltration zones, stromal boundaries. Each neighbourhood has its own character. Let us compare directly. Standard clustering produces scattered, salt and pepper ascendance cells of the same type sprinkled across the tissue. Banksy produces clean, contiguous domains that respect tissue architecture. The difference is dramatic, from demographic groupings to true neighbourhoods.